Hello everyone, Victor is here, and in this video I want to talk about the bond line structures. So far we've been drawing organic molecules showing all atoms and bonds. We know those as Lewis structures. However, this method is quite tedious. It takes a while to draw even a small molecule. Imagine how much time it would take you to draw a molecule with, I don't know, say 20 atoms? You'll just graduate before you finish drawing it. There is, however, a different way we can represent organic molecules. We call those bond line or skeletal structures. So let's check out these three structures that I have here on the screen. The one on the left, this one we call Lewis structure, a full Lewis structure. The next one, the one in the middle, that is a condensed Lewis structure because it does not show every single bond, but it still shows pretty much all the atoms. However, the last one that I have here, that is my bond line structure. And yet, drawing the bond line structure takes mere moments because, as you can see, it's just a couple of lines and then an OH, and that's it. However, what's really cool is that these three structures, including my bond line structure, they show me exactly the same information. So let's talk about how to draw said bond line structures and how to deal with those. Let's start by looking at this structure over here. Go ahead and copy this structure on your paper so you can follow with the steps that I'm taking to convert that into a bond line structure. So first of all, in the bond line structures we only show the bonds, but not all bonds. We show the carbon-carbon bonds and bonds between carbons and heteroatoms, like oxygen, nitrogen, sulfur, phosphorus, etc. In this case, we have 7 carbons and an oxygen. So I have a carbon atom over here, 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 then 4, 5, 6, and 7, and I have an oxygen atom right over here. And while all the carbons in the bond line structure are implicit, heteroatoms are not. So when it comes to the hydrogens, those are implicit on the carbons but are not implicit on the heteroatoms. So what I mean by all of that is that if I start drawing my structure, if I start converting that into the bond line structure, what I'm going to keep is my blue dots, which are carbons. So I'm going to go 1, 2, 3, 4, 5, 6, and 7 carbons. I will connect all of those with bonds, so I will show bonds going like that. I also have an oxygen coming from the second carbon from the right side, so that one should be somewhere over here, which means that I will show my oxygen and I will show the bond between the carbon and the oxygen. Now, I've mentioned that the hydrogens on heteroatoms like oxygen are not implicit, which means that I will have to show the hydrogen on my oxygen. Notice that originally I had my oxygen looking up, while in my bond line structure I have my oxygen looking down. As I've mentioned before in our lesson on the structures in general, on Lewis structures and constitutional isomers, it doesn't matter how I twist my molecule in space, for as long as the connectivity stays the same, it is still the same molecule. So it's perfectly fine in this case to flip my oxygen around to have a molecule have a more round, more aesthetically pleasing form, so to speak. Now, we'll have to show the hydrogen on the oxygen atom not just here, but in every single case whenever we have heteroatoms. If a heteroatom like oxygen, nitrogen, sulfur, whatever it might be, has a hydrogen atom, we always have to show it. So in my bond line structure, if I now redraw it nice and tidy, I'm going to have everything look like this. And as you could see, it took me just few moments to draw that entire thing, and I'm still getting exactly the same information as that huge Lewis structure that I have above that. And one other thing that I want to point out in regards to electron pairs on atoms, those can also be implicit. You notice that in the Lewis structure up above, I could show my electron pairs, but I am not. And also in my bond line structure, I can also show my electron pairs if I need them. Typically, we're not going to show election pairs unless we really need to for whatever reason. Sometimes we need to show those elections for reactivity purposes, sometimes we need to show them because we want to emphasize something about them. Whatever might be the case, if we don't need to show them for any purposes, we can easily skip those. However, just because we are not showing the implicit hydrogens and electron pairs doesn't mean they are no longer there. One of the most common mistakes I constantly see students make is forgetting the implicit hydrogens and electron pairs. And while it's not a big deal if you are just drawing a molecule, it is a big deal if you're analyzing a reaction and come up with a wrong product because you forgot about the implicit hydrogens or an electron pair on your molecule. So while we are talking about drawing the bond line structures, let's talk real quick about do's and don'ts of the bond line structures. First thing first, when you are drawing your bond line structures, always zigzag those. So I'm going to say zigzag over here. So what I mean by that, draw your structure in nice neat zigzags. And please do not make a pike fence. Do not draw it like this. That is a very bad way of representing your structures. So do neat zigzags and do not make exaggerated angles. And I understand that we all have different handwriting, but this is not a creative arts class where you're graded based on your expressiveness or creativity. Line structures are a language of organic chemistry, and it has a very specific grammar to it, so to speak. So if your structures are poorly drawn or ambiguous, you'll lose points for that on the test. As an instructor, when I used to grade hundreds of tests and students drew sloppy structures that were, difficult to interpret or ambiguous, I would just give them 0 and move on. I wouldn't sit there and guess what you mean by that. But I digress. The only time when we deviate from the normal zigzagging is when we are drawing triple bonds or other groups with linear geometry. So, for instance, if I have a triple bond in my molecule, I will show something like that, where this portion of my molecule is linear. So I will show it linear because of the required geometry around the triple bonds and sp hybridized atoms in general. We'll talk more about molecular geometries and Vesper theory in a little bit later, but for now just remember the triple bond should be linear. The next thing that we want to point out when we are drawing our zigzags and we are drawing our line structures is you want to draw your substituents at proper locations. So our substituents should be away from the point. So what I mean by that is if I have my zigzag of a structure, the substituents on the first atom should be looking in this direction. On the middle one should be looking in that direction. On the next one, they should be looking over here. So in other words, I should draw a structure with, let's say, an OH group like that. Couple of CH3s over here. Another substituent over there. Do not ever do anything like that. This is extremely poor grammar, so don't do that. Also, if you were to draw something like this is occasionally okay, so to speak, but use that very occasionally and make sure that it's not, a habit, because when we are starting to use structures like that with dashes and wedges, that can potentially bring ambiguity, because dashes and wedges will represent things in 3 dimensions, and then that just brings a whole lot of troubles if you're not showing your angles properly there. So these are the 2 main principles of good structures. So for as long as you're following those, your structures are always going to look good and will be perfectly legible. Alright. Let's now try to go back from the line structure to a Lewis structure and look at this molecule. So the first thing that I want to do when I have something like that, I want to count my carbon atoms. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11 carbons over here. All of those dots, all of those highlighted positions will become carbons in my Lewis structure. So what I'm going to do, I will draw carbon, 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 then I have 2 more carbons over here, then 1 and 2 like that, then I have one here, one carbon there, carbon, and one final carbon. So I still have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 carbons like in my original molecule. Of course, I still have my bromine, so I'm going to show bromine right there as well. Next, I'm going to add all the hydrogens that I'm missing from my molecule. As each carbon needs 4 bonds, I will have to see how many bonds carbon currently has and add sufficient amount of hydrogens to add up to 4. So my first carbon over here will need 3 additional bonds, which are going to be my hydrogens. Then the next one requires 2 hydrogens. Then I'm going to show 3 more hydrogens over here, 3 more hydrogens on the bottom right. Then the middle carbon, this one, doesn't require any hydrogens because it already has 4 bonds, so I'm not going to show any hydrogens on that one and just skip that guy. However, the next carbon only has 3 bonds, so I will give it 1 hydrogen. The one up above it has 3 hydrogens just as well. Now the next one, I'm going to show 2 hydrogens on that, 1 hydrogen at the carbon next to a bromine, hydrogen here, and finally 3 more hydrogens on my carbon to the right on the top. So that, in a nutshell, how we're going to deal with the bond line structures. And of course here we do have a bromine, so if I wanted to show the electron pairs on bromine, I would do so as well. So now I'm showing not only all hydrogens, but also all the electron pairs. Alright, so let's look at a couple more examples here. I want to take these molecules and convert those into the line structure. So first of all, I'm going to see where I have my carbons. I have carbons here, here, then couple more carbons there, and also my first molecule has 1 and 2 oxygens. So when I'm drawing the overall structure, then I have my carbon skeleton that's going to look kind of like that. I also have an oxygen here and here. I have 1 more carbon there. So now by connecting all of that with bonds, I'm going to have a very basic structure for my molecule. I remember that I need to show all implicit hydrogens on heteroatoms like oxygen, so this oxygen over here in the middle of the molecule, that one does not have any hydrogens on it, so there is nothing to show. However, this oxygen does have a hydrogen, so in my line structure, I will have to show that. So if I redraw my structure in a neat fashion without all of those highlights, then what I'm going to get is something like that. And of course the electron pairs, if I wish to, I can show those as well, although I don't necessarily need to, as I've mentioned before. Now the structure on the right, I'm going to use the same approach. I have 1, 2, 3, 4, 5, 6 carbons in a cycle, then I have 1 2-carbon chain and a 1 carbon chain, plus I have an oxygen on the bottom of my molecule, so converting that into a line structure will give me 1, 2, 3, 4, 5, 6 carbons in a ring, then carbon, carbon in a chain, 1 more carbon in a chain, and of course I have an oxygen, I will stick it down there. Connecting all of that with bonds, I will remember that on the top left I have a double bond, so I will show that double bond, then single bonds for the rest, double bond with an oxygen, then 1 chain, 2nd chain, and that gives me my bond line structure. If I redraw it neatly, then I'm going to have a structure that looks like this. Easy, right? Well, if you want to see more practice questions with answers, check out the links in the description below. Also remember to hit the like button, leave me your questions in the comments below, and I'll see you in the next video.